soil near coastal area, in industrial area, and other places, marsh area, particularly in clay soil, are contaminated with the chlorides and sulfates and bacterial other things. A major component is chloride and sulfates, because from many industries the effluents are going into the soil and it's corroded there. So here, how we can eliminate this chloride and sulfates, these two components, chlorides and sulfates, from the contaminated soil. Otherwise, if you don't remove it, and if you drill a pile and put it in the, and then if you raise a building over there, it will fail catastrophically. You can see the photographs. Main buildings are being toppled. Building is good, the foundation is weak. The foundation is this pile foundation, pile is broken. Various cases, you can see the other photo also. Next, in the wetland, the piles foundations are there. The piles are affected by the chlorides and sulfates, and the reinforcement is snapped, and then the building is totally toppled. Here you can see the same thing. Here the sulfates are reacting with the cement component. This calcium aluminates are there. The sulfates reacts with the calcium aluminates and become converted into calcium sulfoaluminates, and which is an expansive type. Therefore, the bottom floor is being heaped up, and the flooring is completely deteriorated. And you see here, there are so many other things. The sulfates also, you see, that is affecting, and it is falling, and the one block is falling on the other. Here also you can see the building is being toppled, and there are very serious issues, collapsing, and totally it is because of the foundation. Here next you see one building top, you see the piles is snapped. You can very well you can see. Next also you see the bridges, the bridge also falling down because of the attack of the sulfates and manganese. What is happening in the soil? What is composition of the soil? Composition of soil is some mineral particles are there, organic, inorganic matters are there, clay is there, silt is there, and it contains pores, voids, moisture, heavy metals. See these metals. In addition to this, sulfates and chloride, we give it from the industries. It all goes there. So these are the sulfates and chlorides are very, very important for the deterioration of the concrete piles. The sources, this industrial effluents, fertilizer, textile effluent, and decomposition of organic materials. Also, the gas forms. Sulfates are coming from the decomposition of the organic materials. Next, transportation within the concrete, within the soil, is taking place by electro-osmosis, movement of cations to the cathode through pore fluids. Ionic migration, transportation, ionic migration is transport of charged ions to the another electrode. So third one is transport of discrete particles through water. And then the last one is diffusion. This is because of concentration difference. These are the mechanism of ion transport, one place to the other one. Next, see here. This is electro-osmosis. This pictorial explanation is self-explanatory. We can go through that. Next is another one for concrete electro-osmosis, how it is from the pore water, how these things are, ions are going to not for concrete. This is for the soil, how it is within the soil when water is there, the transportation of ions takes place, as shown here, between anode to cathode. The current is impulsed, then the movement is taking place. Next is electrolysis, as you know very well. One at the anode, oxygen is released, at the cathode, hydrogen is released. Next, enhancement of technique. The contaminated solubilization, keeping in mobile state, pH control technique, remediation technique. These are all the enhancement techniques, how to enhance the soil. Next, the sulfates, this is according to the condition of the exposure condition of the sulfates. Next is the mobility of ions, in various elements and some oxides. How they see the element, hydrogen is mobility is much more, 36.23, higher, and all others are less. Similarly, OH ion is 20.64, mobility in water. at a 25 degree centigrade. These are the values. This is how much chloride and sulfates percentages can be there. Chloride percentages there in pre-stressed concrete, reinforced concrete. Next is soluble, water soluble. This is how much this chloride concentration by weight of cement. This is pictorial view, self-explanatory. How we can mitigate this? How we can extract this thing, chlorides and sulfates from the soil. This is a cell we have to form by applying a high ampere, high voltage cell we can make from the underground, and we can isolate. See, this is second figure is vertical formation. We can chloride sulfates to anode and other things to the cathode. We can split it and make the soil neutral. This is how we can prevent by taking out chloride and sulfate from the soil. You can neutralize the soil. Otherwise, this will affect the concrete and steel.